So, in the basic concepts, we have learned about the coordinate system. Next, we will learn about degrees of freedom. So, the minimum number of independent variables or coordinates required to specify the position of a dynamical system consisting of one or more particles compatible with constraints is called degrees of freedom. So here the independent variables means mathematically one variable cannot be written in terms of other variable. Okay. Now dynamical system means the state of that particular system evolves with time. So such type of systems are called dynamical systems. Um, now Now consider a particle moving freely in space. Okay, this particle is moving freely in space. So we can describe its position in that space using three coordinates: x, y, and z. Okay, so now it's in a three-dimensional space, right? It has 3 degrees of freedom. It has 3 degrees of freedom. Now consider two particles moving freely in some another kind of space. Okay, so for the first particle we need three coordinates that are x1, y1, and z1. And for the second particle we need, this is the first particle, and for the second particle we need x2, y2, and z2. So in total we need 6 independent coordinates to describe the position of that particular system. This is a system of two particles. In which space? Not in 3-dimensional space, it is actually 6-dimensional space. It's a 6-dimensional configuration space. So it has 6 degrees of freedom. 6 degrees of freedom, and has, now it is actually in 6-dimensional space. Now configuration space means it is actually an abstract space or mathematical space, purely mathematical. It is just a list of numbers. Now consider there are n particles. Okay, so for each particle we need 3 coordinates to specify its position. Now for n particles it is we need how much coordinates? 3n coordinates. So 3n coordinates are required. So there are how much degrees of freedom? 3n degrees of freedom. So here the configuration space is actually 3n dimensional. Configuration space is 3n dimensional. Now actually what is configuration space? I told you it's a mathematical or abstract space. It's just a list of numbers. Configuration space is basically we can say it like it is a collection of all configurations. It's a collection of all possible configurations of a system. Okay, it's a collection of all possible configurations of a system. That system can consist of more than one particle. Now a single point in this configuration space will describe the position of that system. Okay, system of more than one particle. That is like if for example in 3-dimensional or in a physical space we can use x, y and z coordinates, right? This These three coordinates are used to specify the position of a single particle. Similarly, in configuration space, when we take a point, at that particular point we can we can tell about the position of that particular system. Now remember that it is purely mathematical. It's a mathematical space. The example before I told you, it's just for an analogy, just for you to understand. Now if there are constraints, the number of degrees of that particular system will reduce. What was constraints? It's basically a restriction in motion of that system. Now consider a particle is moving in a circle. This is a circle. My drawing is not that much good. And here there is a particle. Okay. This particle is constrained. This particle is restricted to move only along the circumference of this circle. So first we will think that it can move in two dimensions, in x direction and in y direction. No, but it is only constrained to move along this circle. So the constraint equation is the equation of the circle: x square plus y square is equal to r square, where r is the radius of the circle. This is the constraint equation. And here we can see that x and y are not independent variables. According to our definition, degrees of freedom are the minimum number of independent variables or coordinates required to specify the position of a dynamical system. So here x and y are not independent, they are dependent. One variable can be written in terms of other variable. So here actually this is the center of the circle. Okay. Here the independent variable is angle theta. So this particular particle has only 1 degree of freedom. The particle has only 1 degree of freedom. So constraint is basically a restriction in the motion of that system. It reduces the degrees of freedom of that system. So hence the definition: the minimum number of independent variables or coordinates required to specify the position of a dynamical system. What was dynamical system? The state of that system, that particular system evolves with time. So such type of systems are called dynamical system. Consisting of one or more particles compatible with constraints is called degrees of freedom.